Okay, this is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for class. This is a test of streaming, getting ready for
When one of us is tired out, the other one will hold it down. We're gonna spread the love, we're gonna spread it around. We're all over the city now, and way down in the underground. Come on. To fight the system, to fight the system. It's a
just had to ask, maybe someone out in heaven would hear us down here. We couldn't bear to stand how the people leave us waiting for something up there. Oh, why did you leave? And why won't you come and save us again? Come back to us, spiders. Come on, crush my hands. Let people leave us longing for something not there. Oh, why did you leave? And why won't you come and save us again? Come back to us spiders. Come on, crush my hands. Let peace and beauty reign and bring us love again like you can. Come back to us spiders. Come on, crush my hands. Let peace and beauty reign and bring us love again like you can. So much time we need to ask everything. How did it go? You need it like I did. Come back to us spiders. Come on, crush my hands. Let peace and beauty reign and bring us love again like you can.
Okay, so let's start running through our checklist for arrival.
Come back to us
For Council Landon.
Come on, crush my hands. Let peace and beauty reign and bring us love again like you can. Like you can.
Okay, so I'm simultaneously broadcasting in game and YouTube just for a moment to let you know that audio is going both places. I'm going to shift to a moment to just being YouTube only. So indicate or click on the video above to get it rolling. Otherwise, we're going to get started. I'm going to turn off in-game audio for a sec. In-game audio is off. If you are interested in trying to modify your audio, right now on the screen, let's see, let me see if I can adjust the screen so that you can see it. To adjust audio, the different components, what you can do is you can hover over this little volume icon. Let me see if I can arrange it so you can see it with my face. So if the mix is bad for some reason, you can adjust right here. If you hover over it, come on now. If you hover over it, you get a mix of audio, and you can see that you've got like a master audio. Well, when it shows up for you, you can click it to mute everything. You can unclick it and then hover. There you go. And you can adjust different things independently. So make sure that on mine, I've got my media turned off because otherwise I get an endless feedback loop from the YouTube video above. But you can adjust it so that it mixes well with audio in game and the rest. Okay, just for a moment here, let's run through our checklist and make sure that you are ready to participate in class today. Again, if you want to get out of your seat in game and come down and visit this checklist, you can click on it and get a copy of it so that you can use it independently before you log on. First of all, make sure you're in a quiet location. Make sure your roommates know that you are in class so that they can stop practicing their drumming and for a few minutes or go do their drumming somewhere else. Make sure you've got headphones on, so if you need to speak, you don't have a ton of echo. Make sure you've shut down any extra apps or browser tabs. For example, the YouTube video in which you are watching James Charles address the recent drama. Open Canvas, so you've got that available to you to turn in stuff or to work on different things that we might have. Open Eclipse so that you can work on code as we are working on code. Make sure your VPN is activated so that you can speak in game. Make sure that that happens before you open Firestorm. So those of you that are in game that don't have your VPN activated, you'll need to drop out, activate VPN, and then drop back in. Go ahead and rebake your avatar. So as a reminder, that means going under avatar, going under avatar health, and then going under force appearance update. And what that's going to do is make sure that everyone can see you properly. Then set up your environment, go under world, go under environment and select midday so we all look like we're in the same kind of space. Then set your draw distance to a low number so you get good response when you're in class. So the bottom right, you go down to the little phoenix icon, you set your draw distance to something that's appropriate for your computer. You can see when I go down low, I don't see things far away, and when I bring it up high, I see things as far away as I can. I seem to work pretty well at about 500 on my computer. Although if you have a less powerful computer, then maybe 100. If you have a really fancy graphics card, then you can probably crank it all the way up. Finally, go to the classroom. Our classroom is in the Granville Hall, the main conference hall. You can look on the map to see where we are if you want, and that will enable you to zoom in, to find us if you want. It looks like we don't have anyone else wandering around anywhere. Those little green dots are people, are you, in world. All right, and then finally make sure that you can see name tags over each other's heads so that you know who's talking, so that that's an individual setting. So I have it set up so that I can see you in game, so that I know who's talking. I can see your little, when you speak, as long as you're in my frame, I can see the audio over your head. The little dot becomes little green radars, and if I'm paying attention, I can see you speaking. Okay. All right. Good. All right, so that's our checklist. Let's go ahead and, well, let's see. Let's start just with a word of prayer. Today's auspicious occasion, so let me set up some tools here, and let me just open us in prayer. Okay. So if you'll join me for a second. Okay, hold on. Answering some questions in class. Does anyone see anything on the sign? The sign to my avatar's left, there's nothing there. The little easel down on the floor, there's nothing there right now. Is there a YouTube link? Yep. If you click on the screen behind me, you can grab the YouTube link from the top of the screen in game if you want to watch it outside of game. All right, and yeah, so we can, thanks Thomas for passing that up. And have Frank swing by during office hours because we should get that set up because, for example, right now, what I'm going to have everyone do is get up out of their seat in game, and I'm going to have you go get up on the stage and stand there for a second while I take attendance, and then we will get going with class. All right, let's see. So we are in class 4, and I'm going to set up my grades. All right, there you go. All right, so I'm going to shift gears to be in-game audio for a second, and then we will come back to YouTube audio. So let's see, one sec. All right, I am going in-game. Check, check, check. I am in-game, and now I'm going to stop broadcasting. All right, I'm broadcasting on YouTube, and let's see, the only people I don't have is I don't have Ben Fernberg, and I don't have Frank, and I don't have, that's it. So I know Frank, you're Taylor Burcham. I don't have Taylor Burcham. Not sure if Taylor's there. All right, let me go back to podium. All right, I see Taylor. Okay, Frank, if you're watching on YouTube, can you pipe up in the chat, and then we need to get you to get your in-game working, whatever we need to do to make that happen. And then if Ben Fernberg shows up, could someone have him contact me via I am in game? That would help me to understand what's going on. Okay, posting attendance grades for today now. All right, so let me just reiterate that the checklist at the front of the world, the checklist at the front of the game, front of the conference area, is there to help us remember to get our system set up, um, uh, to make sure we've baked our avatar, make sure we have our VPN in place. Let's see, Ethan Banez and Carson Braze, and I'm saying your last names, although I know it's awkward, but like for example, we've got multiple Ethans and multiple Bens, and so I'm going to say your last name, and I can't even really just say the last initial because Ethan B as in boy and Ethan V as in Vaughn sound the same. So awkwardly, I'm going to be saying full names. So Ethan Banez, can you rebake your avatar, please? Carson, can you rebake your avatar? A few other things. If you need a copy of that checklist, you click on it, it'll download a copy for you. All right, I was going to pray, so let's pray and do that. Dear Heavenly Father, thank you for sort of an auspicious day, getting ready, new week, Martin Luther King Jr. holiday yesterday, new president as of like 10 minutes ago. All of these things weigh on my heart and my conscience greatly, and probably on these students as well to various degrees and capacities. You've given us work to do that is much more in the weeds to learn our discipline, our craft of Java and computer programming and computer science, thinking computationally, Father, so that we have tools for the long run to address the challenges that face our world and your kingdom, our families, our communities, our friends, the places where you have put us. Help us to be faithful with our time and our resources, our attention, and our bodies, that we would put them to your glory. Amen. All right. Whew. That was a rough start. Okay, so let's see. I'm checking over on the left, and looks like we've got good status in the chat. I'm checking what we're broadcasting. We're broadcasting game, and I'm going to shift and broadcast now to our slides, which for some reason have gotten really small. So let me adjust the size of them. All right, there we go. Broadcasting slides. All right, so we are talking about Chapter 2 today. Chapter 1 is an introduction, a lot of things just to make sure that you have a good foundation about how computers work and where they fit in our society. Mostly those are going to be things that you know, but possibly things that you might have gaps and didn't understand for a long time. There's a person I know pretty well who, for the longest time, even into their adult life, thought that house cats grew up to be big cats, like the kinds you see in the zoos, lions and tigers. And it wasn't until he was quite old that he realized, or that someone informed him, that house cats did not grow into large cats. And so every one of us have weird kind of gaps in our education. Chapter 1 kind of helps to address some of those things in computer science. Okay, so let's see. Chapter 2, we are starting a new chapter. So let's real quick check in with Dodger. Here's Dodger recently. He is at home. This is my wife giving him a hug when he was having a hard day. So he is at home today and sleepy. He got a late walk today. He's doing well. What's going on with Dodger? He's a little skinny. We've been watching his weight, so we're trying to watch what we feed him. All right. All right, back to our slides. This chapter, we're going to be talking about using objects. And when we use objects, what's going to happen is we're going to jump into the object-oriented nature of Java very quickly, much faster than we did in Python, because you have some background in this, and so it's good to be able to pick up really quickly. A lot of the structures and mechanisms that happen in object-oriented languages are consistent across multiple different languages, and you'll find that some of the same conventions are present in Java as are in Python. Not all of them, but some of them. It is a different language, and so some things do operate differently. The reason for this is because most computer languages follow kind of an evolutionary tree. So if you're familiar with phylogeny, which is the way in which different genetic sequences mutate over time, you know that they have common ancestors and they branch and diverge, and computer languages are a bit like that as well. When people make a new computer language, they don't start from scratch. They build on ideas and concepts in previous languages, and so they inherit a lot of different structures and forms from previous languages. Java inherits a lot of different structures and forms from the C programming language. And Python, a little bit more recent language, also develops some of its language structure syntax from C, but also borrows from Java, and these languages continue to develop. So it's not like they're developed once and they never change at all. They continue to develop and share different practices from other languages and different syntax from other languages. So languages aren't, completely independent. There are not many languages that are radically different from others. There are a few that are radically different, but most of them have very similar ways of functioning, and Java's like that as well. So in chapter 2, we're going to look at objects, and we're going to kind of go quickly through the first part of this because some of these should be familiar to you. So what we hope to do in this chapter is to learn a little. Let me see if I can shrink this a little bit. There we go. To learn about variables, how classes and objects work in Java, calling methods in those objects, looking about arguments to methods or parameters to methods and how we return values from methods in Java. We want to be able to understand how to browse the API documentation for all of the built-in technologies that are present in Java as well. We want to implement some test programs. Testing is a very important part of software engineering, software development, programming professionally, and even just in research or however you're working. We didn't do a lot of testing in Python. We introduced the idea, but Java has some more sophisticated frameworks for doing testing. And look a little bit at the difference between objects and objects references as well. All right, next slide. Just like in other object-oriented languages, objects and classes are abstractions. What's a little bit different about Java is that Java is exclusively built from objects. There is no linear code in Java. Everything in Java is run from objects. And so, for example, in our first program, let me see if I can pull that up for us. In our first program, here's an example of it. We had a class called demo. Notice that the name of the class and the file name are the same, both capitalized because they are classes. That is a convention in Java and many other programming languages. This class has within it a method which is called main, and main is the default location for where programs in Java begin from. And so rather than starting at the top of the line, top of the file, and running through from top to bottom like Python, Java starts with the main method. And so the very first line that's run is line 8 here, where we print out hello world. We immediately begin running Java within the context of a method. All right. So everything within Java is method-based. So we have these objects. We build our program from objects. Objects have behaviors, and we leverage those behaviors in order to build out the functionality of the program that we want to have executed. Every object, like in Python, has two primary components. We have instance variables and we have methods. Those instance variables are carried along with an instance of a class and can be set independently from other objects, but also as these objects are passed around as parameters, are used within the class, the values of those instance variables remain consistent from one instance to another.
We can manipulate these objects to change the instance variables, and in that way we can kind of create these abstractions of objects that have certain behaviors. Maybe it's a car, maybe it's electricity, maybe it's a user account, maybe it is a abstract idea like a password. All these things can be implemented as objects. In our book, we use the same notation or the same visual language of red blocks to represent different instances of objects. So on this slide here, we're looking at an object called a print stream object. And this print stream object was one of the first objects that we used because it was what we used in order to implement our Hello World program. So this object, print stream object, we found it by using the system static class name using the out instance variable. That instance variable was of type print stream. System.out is an object. Within it, it has some methods. Among them are a method called println and println, short for println, and print. These are two methods that are part of the print stream class. The print stream class also has data in it as well, although we didn't use any of it when we did our Hello World program. Our Hello World program, pretty straightforward, used this object, the print stream object, called the method println on it, passed it a parameter, which is a string, hello world. All right, so we don't know how println works. It is abstracted from us. We just know what its interface is. We know that the interface is the parameters that we pass it, and we pass it a string. We have a contract, which is just a word that we use to describe the behavior of this object. And the contract is that when we pass it a string, that string will be put onto the console. And so when we run that command line, when we run that program, by right-clicking on demo over on the right, that's out of screen right now, but I'm clicking on it and I'm running it as a Java application. You're not going to be able to see the output unless I reduce the zooming. Down here at the bottom, you can see hello world is printed out. That's the contract of println. Println will take its contents and write it to the console. The difference between print and println is whether or not you get a new line at the end of it. So if we change our function so that it's print instead of println, and we run it, the new program as a Java application, we'll be asked to save the file. And you can see there doesn't appear to be any difference down at the bottom, but what's happened is no new line has been written out. So let me add another one. And I'm just going to put my name here because I can't think of anything else creative to do. And you can see it's a print statement and then another print statement. If we decide to run this again, run as a Java application, you can see down in the console here that we have both of those strings run together on the same line with nothing in between them. Although there's two lines within the code, the contract of the print method is that it will print out the string to the console and nothing else. The second one will continue printing out on the console the string and nothing else. The contract, if we add ln in, is that it will also add to the end of it new line characters. So I saved it and I'm running, and now you can see that the output is different. We have a new line character print out at the end, so the output is on two different lines in our console. We can create that behavior on our own by going back to the print method and manually printing in a new line, putting in a new line character, which is a \n, an escape character, the \, and then an n, together the \, and n stand for a new line character. So if I save and then I run this program, you can see we get the same behavior as if I had the println method. So there are multiple ways to skin the cat, if you will, within any programming languages, and this is just one of those different ways we can do that. All right, so the idea of these methods are we don't know how that string gets from the parameter to our console, but that's what it does, that's the contract, and so we use it in an abstract way. Checking in for comments, okay. So objects can be thought of as like appliances. Appliances like a hot water heater. This is an example of not a photovoltaic hot water heater, but just a ambient radiation hot water heater. So what this is a hot water heater where pipes go through the square panel. The sun heats up the water in the pipes, and then the natural convection of the hot water rising causes the hot water to go into that tank. It displaces the cold water, which then goes down into the square panel below it, filled with pipes. The sun heats up the water in the pipes, much like maybe a hose lying on your lawn filled with water ends up having a lot of hot water when you turn it on. The same thing happens with this kind of a hot water heater when it's placed on a roof. When it comes time to use that hot water in the kitchen or in the bathroom, the water is drawn from that large tank and the hot water goes down into your tap or into your bathtub or whatever you need the hot water for. No electricity here, just sun heating up pipes, which is heating up the water. Now we could replace this entire appliance with a gas-operated hot water heater or an electric hot water heater or some other kind of fancy hot water heater that you might have. Geothermal, that burrows down into the ground and gets close to lava to heat up the water. All these would be different ways of abstracting the idea of a hot water heater, but you as a user of hot water don't particularly need to know how it's operating. As long as when you turn on the hot water tap, you get hot water, there are a lot of different ways to implement that. And same thing with classes. Classes enable you to implement different kinds of functionality in different ways. A class is the general name for the structure of an object, and when we create an object, we build it from a class. So classes are the recipe. Classes describe objects that have the same behavior. We know that a string is an example of a class, or if we didn't before, we know now. And so when we create a string in our code, we are actually using a shortcut for creating a string. So let me switch back to code for a second and see if I can show you what I mean by that. All right, so going back into our code, we have the opportunity to create a new string this way. This is a string literal, and what it's doing is just a shortcut for making a string. And so let's set it to a variable. And in this way, we have created a sample string by using a string literal. But we could also do it using a formal object-oriented notation. And we could set a variable called another, and we could use the new reserved word, use the class name, and then call this constructor. Both of these are going to produce two strings, and we could print them out as just to demonstrate that. Replacing our string literal here with our variable. Saving that and then running. And if I can show you down at the bottom, you can see that the output. You know what I'll do is I'll set up a view here so that we can see the output a little bit more quickly. So you can see that the output of this code prints out hello world and then another instance by using variables. And as we go back to the code that we were just looking at there for a second, what you can see is that we did that a couple ways. Because strings are so commonly used, just putting a string into your code executes the string constructor. But we can not use that shortcut, and we can do it formally by calling our class and calling the constructor in our class with the string literal as well. In either case, we get an object on which we can call different methods. For example, we could say example.to lowercase, and that's going to return a lowercase string. All right. And we could also do the same thing on the string literal if we wanted. This is getting a little bit weird, but we could say and that would work as well because both example and the string literal hello are both examples of strings after they get executed. Although again, this is a little bit of a weird example because why would you bother typing out a string with an uppercase letter if what you wanted was the lowercase letter? What you should just do is start with the lowercase in the beginning and you're good to go. You don't need to call that method. Nevertheless, it's an example of what you can do. Okay. So some string objects we've got hello world, we've got goodbye, we've got Mississippi. You can invoke whatever methods that you can invoke on a string. You can invoke them on this particular, on these string literals. When we access system.out, we're looking into built-in variables and built-in classes in order to get the print stream class that controls and writes to the console window. And if we wanted to, we could create other instances of the print stream class. And those other instances, depending on how we configure them, could write to other places besides just the console. Perhaps they could write to a file, or perhaps they could write to a network connection. We could use print stream classes in other ways, but the one that has been set up for us by default when the Java programming language launches, when our virtual machine launches, we'll write to the console. Because all print stream objects are coming from the same class, the same recipe, all print stream objects are going to have the same set of methods. They'll all have println and they'll all have print, and they're all going to print somewhere. Part of the contract of a print stream object is that it's going to print somewhere, and the default one that you get has been configured to print to the console, although that's not necessarily where all print stream objects will print to. All right, let me take a second and just see if we have any comments or questions backed up in chat in game. Looks like we're okay. Okay. All right, moving on. We know that objects of different instances of objects are going to have the same behavior, but other objects are going to have completely different behaviors. So if we think about the behaviors associated with a string class holds characters and keeps them available for us so that we are able to work with them. A print stream object does something completely different. It outputs it to some location. Different classes have different behaviors. They have different contracts. They have different interfaces. They have different responsibilities. A string knows about the letters that are stored within it. A string doesn't know about how to output things to the console. We need classes that work together. We compose them in different ways, calling methods, configuring them, setting their instance variables. All these things cause these objects to work together to produce some behavior that we want. Much like a car, the inside of a car is composed of all kinds of different components. You've got a steering wheel, you've got a gas pedal, you've got a back seat, you've got tires. All these different objects in your car work together to give you the behavior of a fully functioning car, similar to the way that we put objects together in Java. If you imagine a house and you imagine a house being something that's constructed of different objects, all of the windows in the house, they may be different shapes, but they're all going to have the same behavior. They let light through. Perhaps you can open them or close them. They can be configured in slightly different ways. All right. So a quick check. In Java, objects are grouped into classes according to their behavior. Would a window object and a water heater object belong to the same class or to different classes, and why? I am going to just pause for a second and let you think about the answer to that, and then I'll just review it. And then while you're thinking about that, I'm going to switch to in-game audio while we work through some self-checks so we can have you all respond in audio. Okay, what happens when we try and call out the following? It's going to break. It's going to break because println is not a method of the string class. Println is a method of the printstream class, and print system.out is our printstream class. And so if we want a println on it, we have to use the dot notation to access inside that particular object in order to get to it. So we get an error message because that's not present. Okay, so let's move on. Let's get talking about some variables in our world. All right, so let's shift gears and look at our code for a second. You saw that I had already used a couple variables here. I declared them as string type. So one thing that's different about Python than Python is in Java, we have to be much more explicit about the variables that we're using, when we use them, and what the type of the use is. We're not allowed to use a variable unless we first declare it. All right, so let me show you what it looks like to declare a variable. First thing I'm going to do is I'm going to declare a variable of an integer type. And I'm going to use a primitive version of this. There are two different ways of declaring integers. One is an object-oriented way, and one is a primitive way. So first, a primitive way. We'll call it x. I have declared a variable called x, which is of type int, short for integer. I can now use it within the body of my program in order to do something. For example, in an assignment statement, and then perhaps to print it out. That's as a string. I want it as a variable. Save and run, and it should print out okay. Oh, you know what I can do? I can lift this up a little bit as long as we don't use too much screen real estate. There we go. All right, run that. We get a simple 5 on the output. All right, another way that we can declare integers, which actually won't show up until a little later in the class, but which I would like you to know about immediately because you should be using these primarily in your class, in your work, is the object-oriented version. So we've said that classes use capital letters, and so this declaration of an int must not be a class. That's correct, it isn't. And we might like to have a version of integers that is based as a class or an object, and so we can use a capital I integer and declare an integer that way as well. And so we can say x equals 5 and y equals 6. And y is also a variable. It is a variable of type integer. It is, however, declared in a different way. It is declared as a object-oriented version of integer. So we run that, and we have 6. And you can see that it's object-oriented because one of the things that Eclipse does for us is it tries to complete our methods when we type. So if I do X and then a period, you'll see that there's not much that's available to me. I'm not getting any methods. What I'm getting is a bunch of options from Eclipse for ways to edit my code. These aren't actually methods. These are different shortcuts for things I might want to do. On the other hand, if I use Y and type the period, you'll see I get a bunch of classes indicated by the green dot of methods that are present in the integer capital I class. So they're different. They function as integers, but they are constructed in different ways. Which one should you use? Well, you can use either of them. You should be familiar with either of them. But if you're going to make a choice about which one to use and which one to learn, I would learn the object-oriented one first because unless you're doing high performance programming, it's generally better to use the object-oriented one. Okay, so let's shift back to our slides and take a look at where we are there. An integer is an example of a variable. So here we are declaring a variable called width. It is of type int, the primitive version of integer. And a variable within Java is a place to store data. It is like a parking lot in a garage, a parking space in a garage. It is a location to store, a parking space is a location to store a car, and a variable is a location to store data. All right, just like this picture, a parking spot in this parking garage has a name, J53, for example. In Java, a place to store data also has a name. In this example on the slide, the name is width. It is a place to keep that data. The data itself in this code is 20. In the parking lot example, the data itself would be like the car that we're placing in that parking spot. The type in our code here is int. We must store something that is an integer in our spot. And in the parking lot example, that's as if we have named this parking spot as being designated for a particular kind of vehicle. For example, if we say a parking spot is for a compact car, then only compact cars are supposed to park there. Of course, in California, we kind of ignore this, but a parking spot can be labeled with a type of car that's allowed to park there. That is like int when we declare a variable. Perhaps an electric car, a spot that only an electric car is supposed to park at. That would be like a type for a variable as well. So it's just a metaphor of a variable, its type and its data is like a parking spot. What kind of vehicle is supposed to park there, and then the vehicle itself that parks there as well. We can draw an analogy between these two things to understand what's happening. Okay, so our variable declaration consists of 5 parts, perhaps, if we want to think of it that way. It starts with a type. In this example, the type is string instead of int. It has a variable name. In this case, it is greeting. Notice that there's a difference between the capitalization. Capitalization is important in Java. Capital letter designates an object. The lowercase letter designates a variable, or in this context, it's a variable. It can designate some other things. For example, it can designate a method, or it can designate a primitive type as well. We have an equal sign, which says that once we have declared this variable greeting, we're going to immediately initialize it by assigning it a value. And the value that we're going to give it is the string literal hello Dave. And then at the end, we end with a semicolon because all lines in Java must end with a semicolon. If it doesn't end with a semicolon, you'll get an error from Eclipse indicating that you should add that. Any questions about variable declarations? All right, I'll keep listening for typing to see if anyone has any questions about those. Okay, variables, they're just a storage location. They have a name. They reserve some space in memory that you can put things in. You often declare it with an initial value, but you don't have to. So for example, here in my code on line 9, I'm declaring a variable that is called x. It is of type integer. I am just declaring it. It doesn't have a value. But I can also immediately give it a value as well. Here I'm declaring it and initializing it with 10. And then on line 12, I immediately overwrite the value as well. So as I save that, I actually get a little bit of a warning from Eclipse. And Eclipse tells me the following. It says the value of the local variable is not used. Now this is a warning because Eclipse is indicating to me as a software developer that you might be doing something you don't intend. It recognizes that there's some kind of a problem here. It's basically telling me, wait a second, why are you initializing a variable, not using that value, and then immediately changing it to something else, in this case 5? Eclipse is saying, that indicates to me, software programmer, that you may not know what you're doing, that you may be making a mistake. Nevertheless, it is valid syntax, and so I'm not going to call it an error, I'm just going to call it a warning. And by calling it a warning, I'm going to put a little yellow tag over here, an icon on the left, that one can hover over or click on in order to get more information. If you click on it, you'll get a number of different suggestions of things that Eclipse can do in order to correct the problem. Just because Eclipse recommends something doesn't mean that it's going to correct it the way that it should be corrected. So sometimes new students will look at what Eclipse offers you as corrections and will just immediately take it, thinking that it must know what it's doing. It's a computer, and it actually breaks the code. So you have to know what you're doing. But if you do know what you're doing, clicking on this will give you some fast ways to correct it. So for example, if I select that, it's going to remove X and all its assignments. Because in fact, Eclipse is doing a much more elaborate evaluation of what's happening here. It's looking at this code and it's seeing that I'm never actually using X at all. And so if all instances of X were removed, this program would have exactly the same function. And so in this first suggestion, Eclipse is suggesting to me that, hey, maybe what you want me to do is remove X and all of its assignments. And so if I select that and hit enter, it will rewrite my code, eliminating all references to X. Good for the efficiency of my program, bad for the teaching that I'm doing. And so you don't automatically just want to do what it says because maybe that's not what you want. So I just undid it. Okay. So we've got our code, we've got a variable, it's a storage location, we can initialize it. In this case, we have an integer named width, we initialize it to 20, the name is width, the type is integer, the value is 20. We have another example of a parking spot. In this case, it has a name, we presume, we don't know what the name is, but the type is bicycle, and the data itself is the yellow bicycle or the red bicycle that we're storing there. All right, charging on. Here are some examples of different kinds of variable declarations drawn from a table in your book that you can review later if you'd like. Some of them are good and some of them bad. First row, we've seen that one. That one's good. The second one is initializing a variable perimeter with the result of a computation. That's okay. We can initialize it with 4 times the value of width, which we declared previously. If width wasn't previously declared, Eclipse would give us a warning here. It would give us an error in that case. The third line, string greeting equals high. We're creating a variable called greeting. We're initializing it to high. So far, so good. The fourth line is an error. It is valid Python code. It is not valid Java code. And the reason why is because in Java, when we declare a variable, we have to be explicit about what we intend to have happen. In Python, we can assign a variable any of a variety of different types, and we can change those types over the course of our code. In Java, we can't do that. In Java, we must explicitly declare what our variable type is before we use it. And then for the entire scope in which our variable is declared, we can only assign it data that has that value. So what's wrong with this line is that we haven't declared what the type of height is. So if you compare it to the first line where we declare width to be of type integer, when we say height equals 30, it is an error because we didn't put int in front of it, or capital I integer if we want to use the object-oriented version. The fifth line is a problem, 1, 2, 3, 4, 5. The fifth line is a problem because width, in this case, is being initialized to data which is not of type int. Here again is a difference with Python. In Python, we could put whatever type of data we wanted into any variable. But in Java, we declare what type of data will be stored in a variable. We're reading from left to right, so Java says, oh, you're declaring a variable named width that will store an integer, and now you would like to initialize it with the value of 20 as a string, not as an integer, as characters. That's a problem because the string consisting of the character 2 and the character 0 is not of type int, and so we're going to have an error there. The following line is okay. We're declaring a variable, we're just not initializing it. So we can use width later on, but the first time we use it, we better assign it a value because it doesn't have a value just by declaring it. And then finally, the last line here is a shortcut for declaring 2 variables at once. The way you read this is that we are declaring 2 variables whose name is width and height. Both of them are of type int. And so it's just kind of a laundry list of variables that we would like to declare. And it's just shorthand rather than having to put each declaration on its own line. Although we could put each declaration on its own line if we wanted to. Let me pause to see if you have any questions or comments. And I know there's a delay on YouTube, so I'm going to just give you guys a sec. Okay, moving on. All right, so there are a lot of different types that we can use. We've seen int and integer here. Let's write down some other ones. We have a double. Let me rename my variables. We have a double, C. That would be a floating point number. We can have a float. That's a single precision floating point number. And D is a double point floating point, double precision number. We can also use the object-oriented version of these. So that would be a capital D double. We've seen string. We can declare something of type string. So that's another type. So right now on our screen, we've got, let's see, 1, 2, 3, 4, 5, 6 different types. Primitive types. We have some object-oriented types as well. All right, so we can use int types to keep track of integers. We can use double types to keep track of floating point numbers. We can use mathematics to combine both literal numbers and the variables which we declare in them. We have strings, which we can assign string literals, and we can do different kinds of operations depending on what we've got. Java is a little bit less forgiving with overloading the specific operation. So for example, if you recall in Python, you were able to like take a string and multiply it by a number, and that would duplicate the string over and over again. Java tends not to do that. In Java, when you use an operation, it tends to, like a plus or a times character, it tends to have just a very specific, typical, normal understanding of what those operators are used for. And when you want to do more different kinds of operators, different kinds of operations, for example, multiplying a string times a number to duplicate a string, Java will provide a method that does that rather than overloading operators. So just, I actually kind of like that because I don't like being surprised by the way operators work. Okay, there are some conventions with how we name variables. Typically in Java, what we use for our naming conventions is to use camel case. We want to use a variable name that describes its purpose. So I was using letters of the alphabet, which is not very good for naming variables. It's good for examples, but it's not good for real code. You want your variables names to be associated with what it's going to be used for. All variable names in Java need to start with a letter or an underscore character. Once you start with a letter or an underscore character, you can then put numbers later in the variable name. But because the Java parser is going to try and understand your variable name, if the Java parser sees something that starts with a number digit, it proceeds to think that that's a number. But if it starts with an underscore or letter, it understands that to be a variable name. So our variable names have to start with letters or underscores. We can't use any symbols in the names in Java. We can't use question marks or parentheses or time symbols because those are treated as operators. And if we want, and we can't use reserved words, so words that have other meanings. For example, we can't call our variable name integer. We can't name our variable int. Fortunately, within Eclipse, you'll get indication through your editor's color coding that you're using a reserved word if that happens. And so you can pick a different one if you want. A common thing that people do was they will precede their variable name with perhaps my for my, so like my variable, something along those lines to make sure that it's unique. We tend to use camel case. Let me switch back to my code here so you can see what I'm talking about with camel case. So erasing the lines of code that I've got here now, maybe we have a number which is the exchange rate for Bitcoin. And we're going to keep track of that as a double. And we want to know how much is a Bitcoin worth in dollars. And we may want to call that Bitcoin in dollars. And that's equal to something like 30,000 today, maybe a little bit higher. All right, so what you can see here is I have declared a variable type, double. I've given it a variable name, and I've initialized it with a value. I'm getting a warning from Eclipse because I'm not actually using that variable anywhere. If later on I use that variable, that warning will go away. The reason why I put this here, though, is because I want to demonstrate to you that I'm using camel case. What camel case is when you put together several different words, you do intercapping, or you start the next word with a capital letter right here, this capital I, and then the capital D. And so together, someone who reads this can read Bitcoin in dollars. It's a very descriptive name for the variable. It's helpful when you look at the code to understand what it is you're doing. This is camel case. It is named camel case because it is like the humps of a camel. The capital letters in the middle are like the humps of a camel. Now, please pay attention to the fact that I'm not starting with a capital letter. That is important because it communicates something different. Let me give you a different example. What's another example of a cryptocurrency? What's the Ethereum? All right, so we could also say Ethereum in dollars. This is I don't know what Ethereum is running right now. Let's say it's 100. This is a valid variable name, but it's not camel case. This is called snake case. And the difference is that when we start a new word within our variable name, we put an underscore character in that and there, and then we keep it in lowercase letters. And this is called snake case because it looks like a long snake, I guess, if you squint really hard and use your imagination. And this is camel case because it's got humps in the middle. We prefer camel case in Java. That tends to be the standard. Okay, let me check out what we've got here for questions in game. We've got support for Litecoin and Dogecoin. Well done. Okay. Some valid variable names in Java. We've got distance_1. This is good. It starts with a letter. It is snake case, but it's okay. It has a number, but it's not the first thing in it. X by itself, that's okay. It's not a reserved word. It's lowercase. We're all set. Can volume with a capital C. By convention, this is a bad choice for a variable name because it starts with a capital letter. We expect it to be the name of a class, and so we don't want to use this. Down below, we have six-pack, just like my abs. It is a bad variable name because not only is it a lie, do not have six-pack abs, but it starts with a digit, and we can't start our variable names with a digit. Can volume, not a good variable name because it has a space in the middle, and Java treats this as two separate words. Double, not a good variable name. Looks good because it starts with a lowercase letter, but it happens to be a reserved word, and so you'll get an indication because of the color coding in Eclipse that this is a bad choice. Then we have miles divided by gallons. This might be descriptive, but it's a poor choice for a variable name because it has a symbol in it. A better way to describe this would be miles per gallon, M-I-L-E-S, capital P-E-R, capital G-A-L-L-O-N. That would be a good version. All right, marching on boldly, there are comments in Java. Comments in Java are two types. There is a line-based comma, which you've seen me use already. It is two slashes. Everything that follows the two slashes for that line of text, everything beyond the two slashes is considered a comment. If we want a multi-line comment, Java has that explicitly. We have that with a slash and a star to start our comment, and a star and a slash to end our comment. That's the way we do a longer comment. So let me switch to code real quick, give you some examples of this. You see the camel case comment here. This is fine. This is a comment. And if I wanted to quickly comment out a line of code, I could go to, for example, line 9 here. Oh, stand by. My editor broke. Okay, I could go to line 9 here, and I could put two slashes at the beginning. The entire line would now be commented out. Even though there's another comment at the end, that's fine. You can see it turns green in my editor, indicating it's a comment, and then immediately I get an error on line 11 because the function of my comment is to cause Bitcoin in dollars to no longer be declared, and so now I can't use it anymore. When I delete these two comments, it quickly comes back, and I'm allowed to use that as well. If I wanted to comment out multiple lines, I could use the star slash and the slash star to comment out multiple lines. I don't get any errors in my code because there's no code now to actually run. And so I can quickly comment things in and out. If I want to, I can use some of the shortcuts in Eclipse. If I highlight some lines and I come under source and I do toggle comment, or the shortcut on my computer is *7, I can quickly add comments to the front of my line here. And now that I know the shortcut, I can quickly uncomment or comment lines just by using the shortcut. That is a line comment, but I could also do a block comment. Eclipse allows us to do that quickly as well. And you can see that just the part that I had highlighted was block commented, which isn't exactly what I wanted. But if I wanted to highlight more and then add my block comment, I would get a quick block comment. And then I could quickly uncomment that as well. So the editor is very powerful in Java, and using those will make your software development much faster, although it takes some time to learn them as well. All right, we're coming up on 10:15, and so what I want to do is give you all an opportunity to ask any questions or comments that you might have. Anything about your homework assignment is fine, open season on that, or if you have any comments or questions about the material today. Just a reminder to check in on your Canvas check in on the Canvas calendar to see what's coming up. Let me see if I can get that on screen for you. Stand by, and there's our calendar coming up. So we have a homework assignment due today. You have an additional technique for chapter 2 coming up, and you, oh, that's not on screen, sorry. Okay, I broke it. Let me see if I can fix it. Slides, window capture. I broke my window capture. There we go. It looks like I'm Broadcasting okay, but is it? Oh yeah, okay, now I can switch. All right, good. So I'm broadcasting the calendar right now. You can see that in the calendar, we've got Get Your Books coming up. All right, I'm gonna switch audio to being in game for a moment. can hear. Thank you for your attention today. Rolling through chapter 2, going a lot faster than in Python because you've seen some of this before, and I'm looking forward to getting to some of the more algorithmic work, but we've got to walk before we can run, so we need to get all that set up. Thank you for your attention. You are dismissed. Frank, if you're out there, drop a comment in the YouTube chat so I know that you were present today. And also, if you can't get Firestorm to work for some reason, or you know if someone is, also have them check in with me because we need Firestorm to work for audio and everything else to happen. Grab the checklist on the way out if you want. You are dismissed. Thank you for your attention.
Thank you.
Welcome.
Maybe someone out in heaven would hear us down here. We couldn't bear to stand how the people leave us waiting for something up there. Oh, why did you leave? And why won't you come and save us again?
Professor Patterson?
Yeah.
I just wanted to let you know I accidentally overslept, so I came about 20 minutes late, but I just wanted to let you know that I did arrive to class.
Okay, great.
Just in case you had already taken a roll.
Great. Thank you. I'll adjust that.